We'll look at a search and rescue example here with three ships X, Y and Z, line abreast, parallel track, 090 at 10 knots, 4 miles apart, and this is at 1200 hours. X is the northernmost and it's the OSC, with Y the middle and Z to the south. And at 12:30, due to deterioration of visibility to 2 miles, Z is advised to shift to position 2.5 miles on the starboard quarter of X. So let's look at the first sketch. There are the three vessels X, Y and Z, line abreast, 4 miles apart, all doing 090 at 10 knots. X is the OSC, Z is our vessel. We're now asked to go to this position 2.5 miles on the starboard quarter. Now the starboard quarter, of course, will be at a bearing of 225, 180 round to 225, 270 halfway down. Okay, so that's the position we have to get to. So that's the sketch done with the information we've been given. Now what we have to do, we have to draw a line from here to the position we've got to reach, and we know that the distance is 6.6 miles. Okay. Also, when we look at this, if we're here and the OSC is going in that direction and we're going to be on his quarter, then our course is definitely going to be a northeasterly course. So before we actually complete the plot, we can pretty much say what our course is going to be. So what I've done, I've put that line on there and measured 6.6. Now what I'm going to do, and there's different ways to do this, but I'm just making it separate to show you, I've taken this line here and put it here, the green line, and I've simply drawn the line. Then on there, to half scale, notice, now this is full scale, so it's 6.6 miles we have to cover, I've drawn the OSC doing 090 at 10 knots. Then from there, I've scored with my compass our vessel's speed of 13 knots. So this is 6.5 and that's 5, of course, because it's half. And I can see that our course has to be 031 degrees. I know we're going northeasterly, so the course is 031. And in the 30 minutes, we'll cover 5.8 miles. Okay, so between us in 30 minutes, so just be careful, I've got a half scale and a full scale plot. We've got to cover 6.6 miles, but in 30 minutes we'll cover 5.8. So when you think of that, it's not going to take us much longer than 30 minutes to actually reach our position. But our course is going to be 031. So course to steer 031, total distance 6.6 in 1 hour. Now 5.8 times 2 is 11.6 covered, which we got here, 5.8 in 30 minutes. So we cover 11.6 in 1 hour, and this 6.6, don't forget, is the full amount we've got to cover. So 6.6 divided by what would be 11.6 in an hour, multiply it by 60 for the minutes, and we get a time of 34 minutes. So it would take us 34 minutes, giving an ETA of 13:04. Okay, total distance 6.6. We can cover 11.6 in an hour, and that's our distance worked out there. And then our ETA 13:04. Then we want the bearing at a 2 mile distance. So if we look at the problem here, it says find the time and bearing. Find the time when ship Z will be on the new station. We've just done that. Find the time and bearing when Z will sight ship Y at 2 miles. So that's the last part of the problem. So that's ship Y. So all I've done, I've got my compass and I've scored 2 miles. I can do it 2 miles here, of course, because this is a full scale. And therefore, the distance between here and actually sighting the vessel is 2.1 miles. And I've got the bearing there, which I'll read off. So the bearing is 198. And the distance to cover is from there to there is 2.1 miles. We know we'd cover 11.6 in 1 hour, so it'll just take us 11 minutes. So we'll get there at 12:41. And that makes sense. That's 12:30 there, 12:41, 13:04. So in proportion it all looks like that would be a reasonable answer. So just quickly recapping, I've transferred this line here to here. I've drawn the OSC's course and speed. I know my speed, so I can cut that and then work out my course, and then I can work out the distance we'd cover in that 30-minute time when we've completed the vector triangle.